Welcome to Daily Physics. Today, we are going to learn how to draw ray diagrams for converging lenses. Before we move on, let's look at some of the common terminologies used in lenses. First, we start with the symbol of converging lens. It is denoted by a double-headed arrow in an upright position. The lens height defines how tall the lens stands. An imaginary line known as the principal axis runs through the center of the lens, perpendicularly to the lens. The part where the lens and the principal axis cuts each other is known as the optical center. It is found in the middle of the lens. In converging lens, all light rays passing through the lens will converge at one particular point known as the focal point. The distance measured from the focal point to the optical center is known as the focal length. This is usually denoted by the letter F in the ray diagram. 2F on the ray diagram denotes twice the distance of the focal length. As the lens works both ways, there is another set of focal lengths on the opposite side of the lens. Now that you have learned all the terminologies used in lenses, let's explore the three characteristics of light rays passing through the converging lens. Characteristic 1 of light ray passing through a converging lens is that all the light rays will converge toward the focal point after passing through the lens. The second characteristic dictates that any ray that hits the focal point at an angle before passing through the lens will refract to be parallel to the principal axis. The third characteristics of light passing through the converging lens is that any light rays that passes through the optical center of the lens will not be refracted. Let's do a quick recap before we move on to see some real-life examples on how the three characteristics of light are being applied. First, all light rays passing through the converging lens will converge towards the focal point. Second, any light rays that passes through the focal point before the lens will refract to be parallel to the principal axis after passing through the lens. Lastly, any light rays that passes through the optical center will not be refracted. When two or more light rays meet, an image is formed. Let's explore some of the common uses of converging lenses in our daily life. One of the most common applications of converging lens is the correction of blurred visions and farsightedness. Mostly due to aging, the cornea of human eye weakens and are not able to properly focus the light ray entering eye onto the retina. A converging lens is usually introduced in the form of a spectacle to correct the focus of the light rays so that they form a clear image on the retina, hence eliminating the issues of blurred visions that may lead to many other complications. We hope you like our presentation. If you have a physics question, feel free to email us at millennialearninghub@gmail.com or simply scan the QR code and type in your question in the form. We will respond to you soon.